Hello everybody and welcome to our last presentation of the day. It's my absolute pleasure to introduce to you Tim Large, who's a researcher at Microsoft. And Tim is going to give us a presentation on the integration of vision and display using machine learning. As always, we will be taking questions live at the end of this talk, so please leave your questions in the sidebar. I'm now going to turn off my screen, hand over to Tim, and I'll be back to take questions at the end. Tim, over to you.
Thank you very much, Chris. So the title of my talk is Integration of Vision and Display using Machine Learning. I'm a principal researcher at Microsoft in Redmond. I'm a member of the Applied Sciences team there. We're a midterm research and development team that works primarily for the Surface PC business. Some of the products that we make are shown on this introduction slide. So we cover products all the way from Xbox right up to the very large interactive whiteboard products called the Surface Hub and all of the PC products in between. So the title of my my talk is about sorry, there's somebody talking in the background. The title of my talk, talking about camera integration. What I'm going to talk about today is the integration of non-display functions. That's increasing. So we've seen the integration of touch onto displays. We're now seeing integration of antennas and perhaps the fingerprint technology. So a whole range of different input technologies are being integrated into display screens. So far, we have not seen the integration of computer vision, really. Another trend which is ongoing in the industry, which has been a theme for many years, of course, is increasing resolution, which is the power of lithography to make smaller and smaller structures. A recent publication by Canon showed their latest flat panel display lithography system, which can produce 1 micron line space features on Gen 6 panels. So the capability of displays to make ever increasingly high resolution structures just continues apace. And the point there is that the ability of display makers to make structures which are higher than the eye's resolution is increasing. So that is a mechanism that allows for additional functionality to be built into displays. We're also seeing novel pixel designs which are enabling through screen imaging. But the most important trend, which is kind of happening sort of as we speak, is the emergence of very powerful edge AI processors or co-processors, which are enabling new methods of solving some of the computational challenges associated with these systems. So why is display camera integration important? The main reason that we're interested in it is that we're always looking for ways to improve the human-computer interaction, but also to improve the human-to-human interaction, and particularly for large screen devices. Of course, it allows you improved industrial design if you don't have to have a black border around the edge, which is containing sensors. Or perhaps an entirely separate camera device on the edge. For small devices, you get increased screen utilization, and perhaps also you can increase the level of security. So I'm just going to take those topics and speak a little bit about those.